Let's look at a function with the goal of understanding what characteristics of a function would cause the derivative of that function to not exist. So we have a piecewise function here that's got a lot of different things going on. And so we're going to start by looking first at this region around x equals -3. So we're focusing here, and we want to think about the existence of a derivative at that point right here. Now that is a cusp, and I'm going to zoom in. And if we think about a cusp, and the idea that a derivative is the slope of the tangent line, then if I start thinking about creating lines tangent to the curve, that means they touch the curve at a single point, and the fact that that tangent line should be unique, meaning it's the only one, you'll notice that at that point there are actually an infinite number of tangent lines that I could draw to that curve. So this is referred to as a cusp, and the derivative to a function does not exist at a cusp because there is not a unique tangent line to the curve at that point. Okay, moving along. Now we have a jump discontinuity. And the derivative of a function does not exist at a jump discontinuity because the tangent line to the curve, if I'm coming from the left and I'm hoping to create a tangent, I have one behavior. If I'm coming from the right and hoping to create a tangent, I have an entirely different behavior. And notice that those two slopes are not the same, meaning that the derivative would not exist at that point. Now, part of the issue here is our definition of derivative. That is that f prime at a equals the limit as delta x goes to 0 of f of a plus delta x minus f at a over delta x. And so we notice that we would have to consider this limit as delta x approaches 0 from above and from below, or from the left and from the right, and we will end up getting different values. Now let's go ahead and look at our next interesting candidate. That's here at x equals -1. And at this point, the function does not exist. Does not exist. So if we look at the definition of derivative using the limit, notice that the function does in fact need to exist. And in this case, f of -1 does not exist, so therefore it cannot have a derivative. Our next point of interest is here at x equals 1. Notice that we have a corner here at x equals. Notice that we have a corner here at x equals -1. And so we run into much of the same issue that we had with the cusp, that at a corner there is not a unique tangent line to the curve. And so therefore, because that slope of those tangent lines is not unique, the derivative cannot exist. Now our next interesting point is here, right after 4, where we see this oscillating behavior. Because of the nature of the function there, it is not possible to find the limit, as when you let your delta x go to 0, this behavior becomes more and more catastrophic. Now our last point of interest is here at 6. And so you'll notice that there appears, based on the graph of the function, there appears to be a vertical asymptote at x equals 6. Now, we know from our study of limits that in the presence of a vertical asymptote, technically the function does not exist. And because that function does not exist at 6, then the derivative of f at 6 does not exist. So this is a little summary of various characteristics of a function that might cause the derivative to not exist. I hope this helps.